Okay, now we're recording. Thank you, Karen.
You're welcome.
Okay, go ahead, Pierre.
Yeah, and one of the things that we learned from the, at least what I learned from the case study is that it's almost like the third Nephi 8 in terms of the description, because of the storm and the ash fall. It caused everything to be really in total darkness. So you can actually imagine it. What's so interesting about it? I was in the Philippines, so as my wife when this happened, we were still elementary with this volcano erupted. So we have kind of like we remember the ash falls and a lot of lives that were lost. But what the thing is about it is, since the mitigation was really successful because they were able to evacuate a lot of thousands of people out from those provinces. So
Great.
that's in a nutshell that I learned from Mount Pinatubo.
Any questions for Pierre?
Was there anything unique about this volcano?
Well, one thing that's unique that I found out, it's been undisturbed. It hasn't blown for 500 years. That's one of the things that nobody knew that it was there until it actually exploded. So at least in my knowledge, unless people already know about it, but it hasn't blown or did anything of 500 years. I didn't even know that while I was doing the research.
Mm-hmm. And you mentioned this earlier too. Another thing that kind of makes this eruption unique, and I have it right here on the slide. I don't know, Karen, if you can see or if you called in, but you can see right here this line that it was the second largest volcanic eruption of the 20th century.
Oh yeah.
Mm-hmm. So it's kind of hadn't been doing anything for, like Pierre said, for 500 years. Then you get this big earthquake and this massive eruption. Any other questions?
And so that would be what distinguished this volcano is the 20-year second largest volcano.
Yeah, in the 20th century, it was a huge eruption. Mm-hmm. It wasn't as big as Mount St. Helens, but it was massive. I really like a couple of things on these slides that you guys put. For example, you talk about it ejected more than 5 cubic kilometers of material. So if you think of that volume and how much material this volcano pushed out into the atmosphere, that's 5 kilometers wide, by 5 kilometers long, by 5 kilometers tall of material if you do a cube. And it's just a massive amount of material. So great. Other thing that was really big about this one was the pyroclastic flows as well. And so it had big pyroclastic flows coming down the mountain, down the side of Mount Pinatubo, which you have a great picture right here. This is what a pyroclastic flow looks like. It's a little granulated, sorry, but you can see it's this wall of hot ash and just tephra racing down the side of the mountain. So
Dante's Peak.
Yeah.
It looks like a cover for a movie, though. Everybody was saying.
Yeah, it kind of does, doesn't it? They put the title up here. Yeah. No, but that's what it really looks like. Yeah. Do you guys remember kind of who can explain what a pyroclastic flow is for everyone else?
It's dense and it's real hot ash.
Yeah. So if you remember, right, that it gets ejected up into the atmosphere, it's super hot, and then as it begins to cool, the density rises and it races down the sides of the mountain. And it's still really hot. I say cool, but it's still super, super hot. Okay.
It would actually melt you, wouldn't it?
Yeah.
Yes, 1,500 degrees or something like that. 2,000. Yeah.
So I had when I took this class years ago, my professor said that with the instant you breathed in, it would completely incinerate your lungs.
Man,
just very, Very deadly. These and the lahars are usually what killed most people. So great. I think you did a great job. This is a fantastic presentation for you guys to study off of. It's got a lot of phenomenal figures and text. You know, here's another good one with the volcanic explosive index. This is just kind of showing relative size of eruptions. And this is actually a really good one to study. This figure right here is really good to study for the test, because it's going to have a bunch of the eruptions from, not all of them, but a bunch of the eruptions from our case studies that you kind of give you an idea. So you've got here Wawa Springs, which you guys don't know about, but this was a big super volcano. This is Yellowstone. Mount Toba is another super volcano. This is another Yellowstone eruption. But then you've got here, this is the Krakatoa. Okay. And then here's Pinatubo. And that one in Iceland. I don't remember, I can't say it, but it's that one that erupted in 2010. I don't know if you guys remember it. It disrupted all the flight paths. And then here's Mount St. Helens. So Pinatubo, well, I was wrong. I misspoke when I said it. Pinatubo was larger than St. Helens. So forgive me for that. But, and then here's Vesuvius. So you can see this is a great figure that kind of gives you an idea of how big some of these eruptions were. And then it's got this nice scale on the side, which is kind of hard to see here, but if you zoom in, it'll give you more information on it. So I would recommend spending a little bit of time looking at this figure. It'll just help you understand.
Oh, Brother Northrop.
Yeah.
The link underneath will will lead you to the actual index for this particular one. I'm the one who found this. Yeah, if you just copy and paste that, you'll be able to see it in a much better version.
Yeah, perfect. Thank you. That's great.
Did it show Mount Tabora on there in comparison at all?
I don't think this one has. I don't see Tambora.
I didn't see it on there.
I don't see Tambora. I think, though, if I remember right, yeah, Tambora is the largest. I was flipping St. Helens and Tambora. Tambora was the largest to happen. And you guys, just while we're mentioning that, you guys remember what's unique and kind of special about Mount Tambora?
Yeah, I wrote some of it in my deals. Well, about it affecting the Smith farm.
Yeah.
Yeah.
Yeah, exactly. So you remember, it erupted and the Smiths were up in Vermont, and Tambora put even more material into the atmosphere. And what happened is it cooled the earth enough that they were having snow in June and July, and the Smiths' crops all failed. So that they decided to move down to Palmyra. So,
yeah, we went there. We went there in October of 2018, I think it was. And it was amazing that they would say something like that. And I didn't make note of the volcano at the time. Then we started studying. I thought, oh man, there it is.
Yeah,
my wife said the same thing. So,
it's amazing. It really is.
You'd never believe it would do that over here, but man,
I know. It's hard to comprehend the power of these features. Okay, here's the. Okay, just seeing if there's anything else here. Pierre did a great job talking about the human toll. I'd spend a few minutes on going through these, just understanding cost. I don't remember on this test if it specifically asks about the most costly disaster of the volcanoes, but I know on one exam, and I can't remember which one, but I know on one of the exams, it does ask which is the costliest. So just make sure you know and understand that, kind of a general idea. You want to do that? Good night, buddy. Oh, you got my earphones. Okay, so and that's easy. Just quickly write the amounts down on a piece of paper, and you can just know which is the largest, the most expensive. That's probably the best thing to know. So this eruption was $700 million in damage, $100 million, which is just to damage to 16 aircraft. It's got a great breakdown here for you guys.
Is it 30 questions too?
Yeah, I believe so.
Okay.
Yeah, thank you, James, for reminding me. But no, this is a fantastic presentation to study from. It has everything you'll need for the exam. So, and like I said, a couple of things, spend a little bit of time on the human toll. We like to, the test writers, and I've mentioned it multiple times, I didn't write the test. I don't have the ability to write any of the tests or the assignments, but the test writers like a lot of these questions about the science, but also the effect, like the human toll, costs and things like that. So know that.
It's going to be last week's and this week's information, right?
Yeah, it's just going to be the volcanoes. It's just going to be.
Okay.
We're not going to have any landslides, and there's not going to be anything from the last exam.
Just volcanoes. Okay.
Yep. Mm-hmm. Yeah, this landslides is on the next exam, on exam 3. Exam 3 is actually going to cover, I think, it's going to cover like 3 sections. It's going to cover quite a bit more.
I know on some of the presentations that are in the course, there's supposed to be PDF files.
Yeah.
Typically, I can go in and highlight, important parts, but some of them weren't PDFs. They said PDF, but they weren't PDFs.
Really? What were they popping up as? And I can report this.
There was two of them. One of them was it's not a PDF. That's all I can tell you. It's looks like a book.
Oh.
Like the pages of a book. So it looked like they just scanned it.
Yeah.
Well, the ones that say PDF, those need to be checked because they're not all coming up as PDFs.
Okay, thank you.
No way.
Thank you.
There was at least 2 of them like that, and I couldn't do anything with them as far as highlighting or anything like that. So.
Okay, thank you.
You're welcome.
Okay, let's pull this down. Okay, well, let's talk about the Iceland real quick. Now, do we have anyone here that was part of the Iceland group? I can't remember everyone that was in the group, so.
I'm from the Iceland group.
Okay, do you want to walk us through a little bit?
I guess. I will.
You'll do great.
So the Iceland one, they actually thought, or they didn't realize that the volcano was active. So this is a little island off of Iceland. I think it's to the south.
Yep.
And they knew the volcano on Iceland was active, but they didn't know that this one was active. And so there was a couple days before the crack in the earth where the volcano started, there was like, I think 3 days before, there was like 200 earthquakes. And then the day before, there was another, I think it was 100 or 200 earthquakes again. And then at like 2 in the morning, a big crack happened and the volcano came up, or the lava came up, and then it kind of actually built the volcano.
Yep.
And that little port you see right in front, this little town's main way of living is fishing, and so the lava was actually flowing into the port and closing it off. And so they actually, well, I'll back up, sorry, a little bit. They evacuated everybody off the island in a matter of hours, and so there were no casualties from the volcano. And anyway, the volcano kept filling up this little port right here that you can see, and so they started by spraying ocean water on it, and that actually helped save the majority of the town, and it actually helped protect the little port. I don't know if I'm even saying that right. There's a little area right there.
Yeah.
It actually saved it, and it actually made it better for the fishermen. It made it so it's less windy and better. But there was no casualties. There was I can't remember the exact amount of ash that covered the town, but there was tons and tons of ash there. But And I think it erupted for about 5 months, actually. So I think they finally ended it in July, and I think it started in January.
Let's see. I think you've got the dates in here.
Yeah,
Yeah, it started January 23rd and ended June.
Yeah, June.
Yep, great. Perfect. Any questions for Tammy about this? And if you guys look on this titles page, here's the volcano that was built from the fissure eruption right there. And you can see it just flowed right down into the town, right this way, into the port. And here's a great picture of this happening. Anybody, any questions?
More of a comment. It is interesting to me that people would move to the foot of a volcano. I can't see it.
Yeah. Well, you know, in their defense in 1973, they didn't know there was a volcano there.
Yeah.
It was, you know, but yeah. I really think this is an interesting one just because, like you were saying, Tammy, that it starts off January 21st and there's like, and we see this with the other earthquakes, or not, excuse me, with the other volcanoes as well. But you see swarms of earthquakes, and then before this happens, and then this is just kind of one of those. To me, this is kind of like, this one really reminds me of like those volcano movies from Hollywood where a volcanic fissure opens up and it starts spraying lava. It's kind of this, characteristic Hollywood thing. Looking right here, you see the fire fountains coming up. But it's a really interesting, really cool that this happens to this little town. And then they manage not only to save everybody because they get everyone evacuated off, but then they do this really cool thing where they start spraying the seawater back and begin actually fighting the lava back, or not pushing it back, but fighting it as they're solidifying it by throwing this ocean water on, which actually greatly reduced the cost of or the impact of the volcano. Let's see.
That was impressive to me that they did that. Smart.
Yeah. It was really neat.
Cool it off.
Yeah, exactly. It's really neat. I'm trying to think here. Let's look through here, see if there's anything else to add. I also do like this right here. This gives perspective where it talks about the flow being 10 to 23 yards high and more than 40 yards thick on average. And this is a picture of them spraying all that water, trying to stop it. Just amazing the power of these features. And again, here is fantastic, what they were able to do with saving people and then, reducing the damage. So great job. Here's another thing maybe to know as well. More than 400 homes and businesses were still destroyed. There was still a lot of damage. I mean, this thing did run for 5 months. So, and I also thought this was funny going through the slide. I really liked this when you guys said that it's now 20% bigger because of the eruption in 1973. And as she was mentioning, the harbor is now more sheltered than before, which actually protects the harbor and the town from storms and winds. So that's actually really, really neat. So great job. What I'm kind of do, I've got a few more things on each of these case studies we'll just kind of look through after, but just taking a little bit of time to go through them first. So if there's no other questions, we can talk about Kilauea.
Did we talk about what distinguished the volcano?
Yeah, so that volcano was distinguished by that the town that they were all able to evacuate, that they were able to spray the water on it, and that also it was the fissure that opened up in the kind of in the center, not in the center, but on the island near the town. Okay.
All right, thanks.
Yeah. Well, we're going to talk a little bit about the Kilauea, and I don't think we've got anyone here who worked on the Kilauea. So we can just take a few seconds, go through it. So what's interesting to me about Kilauea and just the Hawaiian Islands is, again, if you guys remember about hotspots. Can someone does anyone remember what a hotspot is and can explain it? Let's see here. Not hotspot. I want just do. Okay. So what we'll do is we'll go ahead and look at figures. You guys remember, typically volcanoes form where with regards to plate tectonics? You guys remember, is it along convergent plate boundaries, divergent plate boundaries, or transform? You guys remember? Okay, so it's...
You kidding? I'm on overload.
No,
every week, man. There's so much stuff. It's crazy.
Oh, I totally understand. That happens.
I remember some of it.
Perfect, Tammy. It's convergence. So Tammy said it. Sorry, I'm kind of bouncing between different windows, and it took me a second to see your chat. So it forms along convergent plate boundaries. So let's pull up a picture of that real quick, and I can explain that. Okay, so convergent plate boundary, right? If you guys remember, right, we've got the crust on, the being subducted under one side of the crust. So you can see here, we've got this oceanic crust right here. This is along a continent margin. So the ocean's floor is being subducted underneath the continent. And what happens as it goes down, it melts a little bit, as it starts to heat up, it melts parts, and that melt rises to the surface, and that's where we get volcanoes. That's what made the Cascade Mountains, where Mount St. Helens, Mount Rainier, all those are. That's what caused all the volcanoes up in Alaska. And just kind of the whole Pacific Rim of Fire is along all these convergent plate boundaries. You see these volcanoes forming. Well, there's other places you can get volcanoes as well, and that's at these hotspots. And this is the case with Hawaii, where you just get this plume of hot magma. And we don't know super well why this happens, but hot magma starts to rise, hits the bottom of the crust, and it starts to melt up through, and it can form flood basalts, but it can form what's called a volcanic trail or volcanic island chain, which is exactly what we see in Hawaii, right? We've got the different islands of Hawaii, and that's just as the crust, because it's on a plate, moves over this hot spot that's stationary. It builds out these little volcanoes in these islands. So I gotta move this down. Here we are. That's what's going on in Hawaii. That's what made Kilauea and Mauna Kea. Is right here. The islands are moving out. Actually, I think it's this way. And the volcanoes were built out by this hot spot as the plate moves across it. The other thing that's really interesting about Kilauea, and this is kind of something you guys should know, is the volcano has been continuously erupting since 1938. And then the last eruption, you guys, if you remember the news, was just this last summer. So you can see all that.
So they're saying too that Hawaii will eventually carry Hawaii from the hot spots as the plates move, and it'll drag the Hawaiian Islands with it.
Yeah, so think about it. You've got the plate with Hawaii on top of the plate. And it's almost like it's on, when you're walking through the airport and it's not the escalator, but it's the moving walkway. So Hawaii is kind of like a person on the moving walkway. It's getting pulled with the walkway. And the hot spots just underneath stationary. And so, as the plate is moving here, I'm gonna stop the share for just a second so you guys can see me. Can you guys see me now? Is it showing me?
I can see you on the side.
Okay, let's do this. If you imagine your hand, you've got the hot spot coming up here, and it builds Hawaii here, but then it's slowly moving, and so it erupts again, builds another island here, but the plate keeps moving, erupts again, builds another island here. So you've got this little chain of islands across the plate. Does that kind of make sense?
Yes.
Yeah, that makes sense. I thought it was saying that, the whole island just keeps moving and moving. I didn't realize it was building.
Yeah, it's building. Think of it as Hawaii's growing. Like, actually, there's a new island being made right now in Hawaii, and that's just as a new volcano is starting to erupt.
But isn't that it's not good for anything, really? I mean, it's magma or lava that dries, right? I mean, you can't do anything with that, can you? It's rock.
It's rock. It takes time. You have to break it down. So, as time goes and rains and the ocean and those things, they'll weather it, and then it'll become rich and fertile soils. But that doesn't happen in our lifetime.
Well, I would imagine, isn't that the one where they showed the video of the magma that was flowing like a river? Mm-hmm. There was a guy up the road. I remember that was incredible.
Yeah. Mm-hmm.
That stuff flowing like water.
Yep. It's pretty amazing.
I noted in the video that the trees were dead around there. Yeah.
So you get a lot of, along your magma, aside from just the intense heat, basaltic magmas and lavas. So that's the type of lava coming out of Kilauea, Mauna Kea, and those ones. If I remember right, is 1,200 degrees C, something like that.
Yeah.
And so just super, super hot. And so that's going to kill anything nearby. And then on top of it, you've got all the gases and, a lot of things that are just a major problem for life. And I don't know if you remember on the news last summer when this was happening, but there was whole sections they were quarantining off saying, hey, we've got problems here. We've got, a whole bunch of nasty gases that we think are in these areas coming up. And so that's another reason along these flows, you see a lot of death. You get a lot of those gases coming up. This is also kind of an interesting little side note here that they tried dropping 2 600-pound bombs in the lava channels. We don't do that anymore. As you guys see, it's not worth it. Kind of a fun little fact, but there won't be anything on the test about this. So
I wonder what would happen if they dropped an atom bomb in there.
No, you'd have a lot of problems.
I would think it's probably just split something.
Mm-hmm. Okay, here's a good thing to know. I don't remember if this is on the test or not, but you've got Mauna Loa, which is the big volcano on the Big Island, and then you've got Mauna Kea, you've got Kilauea, and so Kilauea is on Mauna Loa. It's kind of off to the side, but they both share the same magma chamber. So they're kind of the same volcano, just two different, I guess, if you will, eruption points. Does that kind of make sense? So that's a good thing to note. And then, oh, great. I forgot. So here's that slide again, Lisa, and that I was kind of trying to show with my hands. So you can see plates moving this way, it's taking the islands with it, and it builds these new ones here, as it's erupting.
Okay.
Yeah, this is easier to see.
Yeah, that's better.
And you can see here, this is that new island that's being built right now.
It's amazing. Mm-hmm. And they need more area right now anyway. A lot of people.
They've got a lot of people. And it's real expensive land there. So maybe, get some beachfront property over on, I'm not even going to attempt to say it. Okay. Now this is a good slide too. this is a really good slide for you guys to spend some time on. Make sure you know. It's talking about here, right? You've got the hot spot. You got the slow drift of the Pacific Plate. And that's carrying it across the hot spot. You get the islands building out. But what I really want you to look at is right over here. You've got rock type. Kilauea is basaltic, Mauna Loa basaltic, Mauna Kea basaltic. So all the lava coming out of here is a basaltic lava, which means it makes basalt. That's the rock that it makes. And that's important.
It's black, wasn't it?
Yep, that's right. Basalt is black. And I'll show you some pictures of the different, I can show you some pictures of the different rocks. But who remembers the 3 types of volcanic rocks?
Oh, yeah,
And one start with an R something.
Yep.
I can't say it.
Yeah, that's right. Rhyolite.
Yeah,
Rhyolite, and then there's
andesite or something.
Andesite, perfect.
Andesite, that's it. Yeah.
And then the last one, we've been talking about it.
Salt.
Yeah, basalt. That's right.
Salt.
And so, if you guys, I don't know if do you guys remember what types of volcanoes, or how do I want to ask this? What rock forms from the most explosive volcano? Do you guys remember?
The R one, rhyolite.
Yeah, exactly.
Rhyolite.
You got it. Rhyolite. Rhyolite is the one that comes from the really explosive volcanoes. That's because rhyolite has more silica in it. And if you remember, silica and more kind of syrupy, more viscous lavas and magmas create a more explosive volcano. Then you've got andesite, which is kind of the medium in between, right, and explosiveness. And then you've got these basaltics, which aren't super explosive, but they're kind of that classic, right? The big rivers running down side of the mountain, the big, beautiful fire fountains, things like that. Okay. So we've got one right here. We've got Mauna Loa, Mauna Kea, which, Kilauea, these are basalts. That's what these are making. So we talked about Pinatubo. What type of rock do you guys think Pinatubo would make?
Basaltic.
Nope, not quite. Remember, we got to think about explosive.
Oh, it's rhyolite.
Yeah, it makes kind of a mix of rhyolite and andesite. So, and the reason is, and that was kind of a trick question, but the reason is Pinatubo is a really explosive volcano. But remember seeing that chart I told you guys to look at that was on that presentation? How big was Pinatubo in explosiveness compared to like Yellowstone and those super volcanoes? It was way smaller. Those super volcanoes produce purely rhyolite, whereas the smaller, the ones like Mount St. Helens, Tambora, those ones will produce some rhyolite, but mostly andesite. And that's good to know for the test.
Brother Northrop, when I was doing the Pinatubo, it says basalt.
Does it?
Yeah, it did.
You can get basalt there.
So that's what I put in the presentation. Okay.
Just know that, if it asks, put you want andesite.
Andesite.
And the reason it probably says that is you can get, remember how I said, you can get either rhyolite and andesite from there, from Pinatubo. You can also, you get what's in the magma chamber, what's called fractionation. And that's basically things kind of splitting up and dividing. And don't worry about it. You don't need to know it. But what it means is the minerals and the chemistry can change a little bit in different spots, and you can get some basalts.
Okay, that's just good to know.
Yeah.
Now, I would imagine all volcanoes, when they blow up, if they do erupt big time, they're throwing rocks out with the ash and the pyroclastic cloud stuff.
Yeah, that's right.
Be accurate?
Yep.
Okay.
So when, and that's the explosive ones. So like these shield ones, they're not thrown out as much ash, right? Right. Because you can see the videos of them. Yeah. It's more, it's sending out and oozing out the lava. And I think a good way to think of it is it's oozing lava when compared to Mount St. Helens. You know, I'm sure you remember, we've all seen pictures and videos of that, and just, you know, the whole side of the mountain just blows off. But they're still shooting out rock and ash and all sorts of stuff. So you're totally right in thinking that.
Well, and how it melted those people that were sitting there in cars and stuff looking at it and all this stuff.
Yeah.
That was amazing. Holy cow.
Yep. Yep. Okay, a couple other features to know about Kilauea is, first, you've got here, and this is a good one, you get the fissure eruptions, which is kind of like what we saw in Himalaya in Iceland. You also can have, you have the main Kilauea right here, kind of up in here, where kind of all comes from the summit of the mountain. And then up there you also have, and I don't know that they have a picture on here for you. They also have a lava lake. So I'll show you a picture, guys, a picture of
Amazing.
the lava lake. Oh, I can't even spell Kilauea. So here's a lava lake. Basically, it's a lake of lava. And so Kilauea has one of these. So know that Kilauea can have, has a lava lake, can have fissure eruptions, you know, has the flows. Also know that Kilauea has the two types of lava flows coming down it, right? If you guys remember, there's the Pahoehoe lava, and then there's the A'a lava. And remember that Pahoehoe is that kind of ropier one that comes down almost more like a river, like what you were saying, James. And then you've got the A'a, which looks like that big crumbly wall of, almost looks like rock, but it doesn't look quite right. And it just kind of crumbles and moves forward. So
creepy looking stuff.
Yeah. Yeah. So let's see. Anything else I want to hit on Kilauea? The big thing with Kilauea too, I'm going to move this back up for you guys, is there's not really too many. I mean, you've got the boat, the tour boat, right here in July 2018. You don't need to know that for the test because the test was written before this. So, and it hasn't been updated. So there's no questions on this, but this is a really interesting little story to read. But just the biggest thing to know is there's not been a lot of deaths, 2 deaths, a bunch of injured, some earthquakes. More what's happened with Kilauea is the economic impact, right? I mean, even just this last summer where whole neighborhoods, a fissure opens up in a neighborhood. So what's kind of significant about Kilauea is that it's opening up in neighborhoods. It's affecting a lot more towns, if that makes sense. Okay, let's see.
Well, that's when was it Kilauea? Was it Kilauea where the boat got rained on with?
Yep.
Yeah, man, makes you think of Dante's Peak when the rock comes through and gets his wife.
Yeah.
In the top of the head. It was burning people, right? I mean, scary situation.
Okay, do we have anyone here from Mount St. Helens? Okay, I don't think so. We're going to kind of fly through some of these so you have a little bit of extra time to talk about any other questions. And I do want to go over, I've got one more PDF I want to just go over with you guys. Okay, so Mount St. Helens, big thing about Mount St. Helens, it's the most explosive, destructive eruption in the history of the United States. I mean, you look at this picture right here, you can see it, right? It blew off half the mountain. You know, it caused hundreds of millions of dollars in damages. You know, I'm from a little town in North Idaho, and my town was covered in ash when this happened. You know, and that's hundreds of miles away, you know, and so that's a kind of a big thing to know. This background slide is fantastic. This is a great slide for you guys to spend a few minutes on. Make sure you know the volcanic explosive index is a 5. It's a stratovolcano. You know, that there was a huge avalanche. And that's a kind of a big deal with this volcano. There's a huge 2.5 cubic kilometer of debris that came down the side of the mountain. And that's killed quite a few people, caused a lot of damage. created a lake, all sorts of stuff. Lots of ash, got lahars. And then very characteristic of a stratovolcano, blew off the top of the mountain. So it was over 1,000 feet shorter after the eruption. So kind of spend a little bit of time looking at this background slide here. Won't focus on that. Here's on the location. Eruption sequence, there won't be too much on the exam for. Still good to go through just because it's interesting. At least I find it interesting. But then again, I'm a geologist, so I like weird stuff like this. And this is a good picture here that shows this eruption. And what I think you guys should pay attention to in particular are these two sections right here where you get the big explosion coming off and you get this big slumping off of the side of the mountain. And this is where that big avalanche comes from, that big debris avalanche, okay? And that's what's to note here on this is really good. And then that pyroclastic flow then comes down the backside of that. And again, here's the range of the ash flow deposit. My hometown is right here. And so you can see we were like in the center of it, you know, but this was reaching all the way out, you know, to the Midwest. This is where ash was coming. You know, you can see half-inch ash out here. There's even ash out in Oklahoma. Gives you an idea. This is one of those Plinian eruptions, if you guys remember from the tests, or not the tests, the readings, right? Vulcanian and Plinian. There's the two eruptions that appear to be similar. It's just that Plinian is significantly larger than the Vulcanian eruptions. That's those ones that sends the ash up. This is a good demonstration of that. A Vulcanian eruption would have just put ash right in here, and a Plinian eruption, you know, covers a significantly wider swath of land. This one just talks about Mount St. Helens and relative to the other mountains. It's the farthest west of the Indian and Cascade Mountains. I don't remember anything going on the test there. Although I would know this slide right, this bullet point right here, that these volcanoes are produced by the Juan de Fuca plate subducting right over here under the North American plate. That's what's going on here. And as you think about, if you remember with earthquakes, you've got the big San Andreas running down in California, which is not, that fault is not a thrust fault or a reverse fault, right? That's a strike slip fault. That's because we have a plate boundary change right here in Northern California. All of a sudden it goes from a transform boundary to a convergent boundary. So that's why you get these volcanoes here. So know that you've got the subduction of the Juan de Fuca plate that creates this volcano. Does that make sense to everybody?
Yes.
Okay, perfect. Let's see. This is a good one. This is good, just interesting, an interesting slide here. Some good things to know. I don't know how much, I don't think there's going to be really too much from this slide, but it's still good to know to understand volcanoes and these big stratovolcanoes. This first sentence is really good. Everything within 8 miles of the eruption was instantly wiped out and then sent shockwaves that took out another 19 miles of trees. That's how powerful these eruptions are. So know those kind of things like that. Quick facts. You got dacite, which is what is produced here. So I'm just gonna dumb this down. This is a more kind of broken down type of geology here that you guys don't need to know. Dacite is closest to andesite. Okay, so that's what that is. It's slightly more quartz than andesite, a little more plagioclase than rhyolite. It has to do with minerals, but you'd be fine just putting andesite. That's what it's closest to. Okay, and then human toll. You've got $1.1 billion. You've got town surrounding areas, mountains have become tourist attractions, which has helped the economy in later years. 57 people died. and thousands of animals were killed. You had a bunch of elk and a whole bunch of stuff like that. There's one other thing in here that I'm going to post for you guys. There's a story about a gentleman, and I'm going to post it in the announcements today or after this, that you guys should go back and read, that there may be a test question on. And it's just not in here that I saw, just about a guy who didn't want to evacuate. And I can't remember. I feel like there was a question. There's either a question on that case study person, or there's one in the coming case studies for landslides that I know there's a question for. So I'm gonna come back, go post that.
Sorry, Brother North. Isn't it Harry Truman? I read that part. That was like he didn't want to leave when Mount St. Helens erupted.
That's right.
Yeah.
Let's see, where is it? Oh, yeah, Harry R. Truman. There you go.
Yeah, that was really sad.
83-year-olds. Yeah. So read this story. Be familiar with it. There may be a question on it. And kind of the reason I think they would put a question on things like that is emphasize the point, listen to the authorities, evacuate when an evacuation order is given. Okay, any questions on St. Helens? Okay, we are gonna hop over to the next one. Let's see. Okay, that's that. So then we're gonna do Krakatoa. This is my favorite volcano. So, and I did a report on this volcano when I took this class. That's probably why I like it. Okay, Krakatoa, it's in the Philippines, or kind of, that area in the Pacific. And when it erupted, it's still around. It's still erupting. I think the most recent, it erupted in the 90s or early 2000s. But it's significantly smaller now. It's now, when it erupts now, it's a Vulcanian level eruption. It's no longer Plinian. But in 1883, they had this huge eruption. And it really is one of the most catastrophic events in the history in history with humans. So we'll go here. You can see it's just this, it's a little Pacific island. There's not too much. There's a little town a little village.
Marco, that's the Pinatubo one.
Is it?
Yeah.
Krakatoa?
Krakatoa is in a PowerPoint presentation.
Say that again.
I'm not seeing the Krakatoa. I'm seeing the Pinatubo.
You're not seeing? Oh, that's why. I'm sorry. It's the way it's sharing.
Okay.
There you go. It should. Now do you see it?
Yes, now I see it. There it is.
Sorry about that, guys. I thought I was just on a normal screen share. Okay, so here's the current volcano that's still there. This is location. It's a little town. There's a little town on the flanks over here. And in 1883, there was just this huge eruption that occurred. It was a 6 on the volcanic explosive index, which is huge. And it shot out ash and pumice, a whole bunch of tephra, sent out big shock waves, caused a lot of damage and problems. Let's see here. I gotta move these up. Sorry, when I maximize it, let's see if we maximize it. My computer doesn't like to maximize these presentations sometimes. It's an older computer. And when I maximize, the formatting gets fixed. But basically, Krakatoa was a big stratovolcano, magma chamber underneath, pressure built up, blew its top. Same kind of principle as Mount St. Helens, as Pinatubo, as Tambora. And let's see. Here you go. This slide, this is what is important. It was a massive eruption that caused large tsunamis. That's what killed most people with this volcano. We send out big, large tsunamis that went throughout all kind of that area in the Pacific right here. Here's Krakatoa, went out all through here, and these tsunamis would come through and devastate entire islands, not just villages, entire islands. And so that's what made this volcano so devastating. As a matter of fact, on this one, this is a great slide. Estimated 36,000 deaths from this volcano. 31,000 of them were caused by the tsunamis. 4,500 were scorched to death by the eruption, which included the any landslides, things like that, and the pyroclastic flow, which most of it would have been the pyroclastic flow that caused these 4,000, roughly 5,000 people that lost their lives. So that's an important thing to know about this volcano, the tsunami. And what caused the tsunami wasn't things falling into the water. It was the shock wave, just that sheer force of the eruption, the sheer explosiveness. This eruption was very similar to Mount St. Helens in the fact that the whole mountain blew up. You know, the whole mountain exploded. And the reason is because ocean water got into it, into the magma. And that ocean water caused just a huge explosion. Go down here. Eyewitness account. You don't need to know too much about it, but this point right here about Edward Munch. So Krakatoa sent a lot of ash into the atmosphere, and what it did is it actually cooled the earth a little bit as well, like Tambora, but what it did also is it changed the sunsets. So the sunsets became significantly more red and purple, a lot more vibrant. And that's not just for the, you know, the Pacific. That was over in Europe and the Americas, all across the planet, this changed. And that had an effect on art. And we see that with paintings like this by Edward Munch. This is the Scream, a very famous painting. Many historians think that this painting was influenced by the sunsets that were happening at this time from that volcano. So Krakatoa actually influenced European art.
Yeah, that one they'd call, in today's society, they call that, what is that art? They call it modern art.
Yep.
It's not beautiful, it just looks like a child did it.
Yeah, expressionism, I think.
Yep.
Yeah,
an
that
expressionist.
too. Yeah.
An expressionist, slightly surrealist painting.
Yeah.
My wife's an artist, so I know all these fun things. She likes.
Hey, by the way, this presentation's the one that didn't have the PDF.
Okay,
It's
it was
Krakatoa.
it was in the book format.
Yeah, when you show, both of them. One's in the book format, and then you go to one says PDF. It's in the exact same format as the first one.
Okay.
Can't do anything with it.
Okay. And then there's one other thing on here. One other very important thing about this volcano, and that is that it made the loudest sound ever heard on the planet. So the explosion from this volcano was heard in the United States, on the west coast of the United States. It was so loud. It was heard over 3,000 miles away. And that was just from the sheer volume and power of this. So those are kind of the interesting thing, the important things to know. Here you go. It was heard 3,000 miles away, and it created 120-foot tall tsunamis.
Man.
So and I love this. This is before, you got this beautiful little mountain, and after, there's literally no mountain left. That's how bad this explosion was. So that should cover the things you need to know about that.
Wonder if people still live there.
Nope.
Or did they live there before?
There were people there on the island. There was a village, but it is now an uninhabited island.
Yeah. Wow.
Okay. Close that. Now let's see if I can find. There should be. I guess there we go. Tambora. We'll go through Tambora relatively quickly. Let me switch the screen now so you can see that. Share. Okay. Can you guys see Tambora now?
Yeah.
Okay, great.
Yes.
So we already talked a little bit about Mount Tambora with Joseph Smith. Occurred in 1815. It was a big stratovolcano. And then here's some good facts about it. Expelled 140 gigatons of magma. So there was a lot of rock that came out of this, making it the largest in explosion. Saying there, 95% of the mass of the ejecta was erupted as pyroclastic flows. Of the ejecta, okay, yeah, but 40% of the mass of the material of these flows ended up as ash. So big ash cloud, and that ash cloud is what caused the cooling. So it's good to know. 6 times more. So the eruption injected 6 times more sulfur into the stratosphere than Pinatubo. And that's what caused the cooling. You see here, they say this formed this global sulfate aerosol veil, and that's what caused the cooling of the Earth. Just know that it cooled. You don't need to know that it created this sulfate aerosol. Just know the ash circled the globe, cooled the Earth. Really cool figure right here that just shows the layering of the ash and things like that fell. And some interesting facts about Tambora was, first in 1812, they thought this was a dead volcano. They didn't think it was going to erupt anymore. Kind of a similar story with Pinatubo, right, where it hasn't done anything for hundreds of years. People are like, nothing's going to happen. We don't have to worry about it. And then, it has this big eruptions with in 1815. I'm not going to pay attention too much to this here. Sorry, I'm just trying to kind of hurry a little bit for you guys because I want to get to one other thing. Effects on climate. We see that. Remember that the climate particularly affected the northern hemisphere, and that's what sent Joseph down to Palmyra. Here's the other couple of good things to know about it. Created strong whirlwinds. So this is probably the pyroclastic flows. Created tsunamis throughout the area. And these ones were done as the tsunamis were these big flows hit the ocean and the shock waves that just pushes the water. Think of it as, you've got all this force, all this wind, all of a sudden just creates this giant wave. It's big along a subduction zone of the Eurasian plate. And again, just make sure you know that where all of these are forming. So like Tambora, Krakatoa, Pinatubo, Mount St. Helens, these are all forming in subduction zones. The one in Iceland is forming in a divergent plate boundary, so it's pulling apart. That means that the crust is really thin there, and it's easy for the lava to punch through and create a volcano, melt through and create a volcano. This is a really good slide. Spend some time, just make sure you understand these. The island was desolate. All the communities were killed. Roughly 10,000 direct deaths. We do think, though, that it caused over 80,000 deaths from starvation and disease. That's resulted from the cooling, which made for bad crop harvests. This is a good first eyewitness account. There won't be anything on it. And then, the other thing you guys need to remember too about Tambora is it helped inspire Mary Shelley to write Frankenstein. Now, do you guys, any of you remember how that influenced Frankenstein? So what happened is Mary Shelley and her friends, it was a cold summer. No one wanted to go outside. So her and her friends would get together and they had a competition they decided to have a competition to write a story, a scary story, so that they could stay inside while they were cooped up inside because of the cold. And for that competition, she wrote Frankenstein. So that's a good thing to know. You should know that as well. And similar to 3rd Nephi 8 as well, very similar, kind of like what Pierre was saying with Pinatubo. Just a big volcano. So this is another good presentation. Spend some time going through it. And now I kind of want to end the last couple of seconds with just going with some of these. Each case study had a list of prompts that you guys were supposed to, or that the groups were supposed to answer. This is a PDF of those prompts with the answers. And what I'm going to do is I'm going to post that after this. And you guys can go through this. It's going to have the answers to every question. You guys can go through it, read through it, and make sure you understand it. There's also, go ahead.
Are you posting that on our email, or?
I'm going to post it in an announcement and shoot it as an email.
Okay.
So you guys should get it in both. And it's just, and so you guys should have access to that. The other ones you guys should go through, and these case study presentations are posted. They weren't done by groups. This was done by the course writers. Is Santorini, Greece. And I'm going to post the link to that one as well. You guys already have access to it, but it's kind of frustrating to find. So I'm going to repost the link to you guys to see this presentation. So there's Santorini, Greece, and let me see, kill it. Make sure, got it, Tambora, and Vesuvius. So Santorini is the Minoans. That's what's important about Santorini. It's the eruption that we think inspired the legends of Atlantis. Okay, and this is a volcanic eruption. And then we've got the famous Vesuvius. That's Pompeii. I'm also going to post this one. You guys can go through it. It has everything you'll need to know on it. And then with these questions, you guys will be set. But with Vesuvius and Pompeii, basically the things you guys should know are, with Vesuvius, you should know that it covered Pompeii and Herculaneum. Remember, there's 2 towns that are destroyed by Vesuvius. And super famous. We've got all the bodies. Another thing you guys should know about Vesuvius, it dropped 30 feet of ash on these towns. So that's why they're excavating down to these towns to find the bodies. They have to excavate through 30 feet of rock and ash that came from the Vesuvius. Okay. And then with Santorini, know that is on an island in Thera, called Thera. It's, let's see, the big thing to know there is on this island there was this actually really advanced civilization called the Minoans. They were a seafaring people. They were like the Greeks. And what happened is this eruption basically caused this entire civilization to go extinct. And many people project that the Minoans would have, over time, probably taken over all of Greece. So it's a big deal. Right? The civilization was wiped out. They were the dominant. They were the most advanced culturally, and they were the most advanced with their art, their science, their warfare, their seafaring. And so there's a pretty big deal about that. And that's kind of the important thing to know on that. So yeah, and I'm going to go post these now after this. But so post the link to these 2 presentations and this PDF. It'll be in a announcement, and I'll shoot it out to you guys through the messenger email thing. That way you guys will have it in 2 spots. You should have easy access to it. But,
so then these questions we have to go through and find all the answers to?
Nope, you don't. So the questions are here. The answers are here below.
They're at the bottom.
Yep.
Oh, they're at the bottom. Oh,
yep.
okay.
The smaller
Okay.
text is all the answers.
Mm-hmm. Oh, okay.
So you guys can study from that. And this will make it so much easier to prepare for the test. Your case, so spend quite a bit of time on this and spend time going through the presentations, and you'll be set with case studies. You should have everything to a T. Okay, any other last questions? Oh, and I'm also going to post this video. Okay, sorry, I know that was kind of long, but I just wanted to make sure you guys had everything you needed for for this. I know the case studies, it's kind of hard to know what to study off of the case studies. Looks like we got one in chat. So take your time. Don't be afraid. You know, I'm okay. With these tests, it's totally fine. I think it's a good idea to not take them until Thursday, Friday, Saturday. Take plenty of time to study, to go through the material. Other thing that I always tell everybody as you prepare for the tests, start with a prayer in your studies. Maybe a scripture. Just open your minds to the Spirit. The Lord knows how these volcanoes worked and all this information, and He can help you retain the information. And I promise you that will make a big difference as well. And then when you take the test, as always, start with a prayer, and you know, maybe you read a verse of scripture, and it'll work out. You guys can do it. You guys are all super bright. You guys, I've been super impressed with all of your work this semester. The case studies have been fantastic. Your discussion boards posts are always really good. You know, you guys know what's going on. So I have faith in you guys. And if you're not happy with your grade on the test, shoot me a message. We'll get some extra credit set up for you so that you can earn plenty of points back. No one should fail this class. If you reach out to me, I'll make sure, I'll do everything I can to make sure you guys pass. So don't worry about that. Okay?
Appreciate it.
Okay,
My
thank
pleasure.
you.
Thank you.
Thank you.
And
Thank you.
good luck, you guys. And I'll get back. I'm posting. I've been going through the discussion board, so you should also see some posts from me on there tonight.
Okay.
So, all right.
That's great. Thanks.
Yep. Thank you.